Hello, everyone. My name is Eric Moore. Thank you for joining me today as I present on advanced Autogen patterns and Gen AI ethics. Everything I share today is my own views and do not represent the views of my employer. So the first part here is advanced Autogen patterns. Some of what we'll be talking about are some of the limitations of multi-agent systems as of today. And then I'll be diving into demonstrations of some advanced patterns and closing with some of the implications of O1 preview. So the first pattern I want to talk about addresses, all of these patterns really address these limitations that are prevalent with multi-agent systems. So the first is context becoming too long. In a dynamic chat, you're constantly appending to the length of the context. And as you get past 20, 30, 40,000 tokens, your quality of response based on information from tokens further back in context becomes lower quality. So your needle in the haystack, the bigger the haystack is, the less effective the LLM is using the full width of tokens within that space. So we see that in dynamic chats, where as the dynamic chat exceeds the number, a number of tokens, your quality of response drops off. You can even have the original prompt for the chat rotate out. Lots of ways to address it, but it is a significant issue. Another problem is where we have it taking too long to generate a response. So if I've got 4 agents, they're in a dynamic chat, I'm allowing multiple rounds, it might take 2, 3, 4 minutes to come back with a response, if not longer. Now, whether or not that time is worth it for the quality of response, regardless, that's a long time to wait. People aren't used to that from these kind of systems. So that's another significant limitation. Loops. So I consider loops ultimately the symptom of a core issue, which is figuring out when we're done, right? Termination behavior. So if I assign a chat a task, how do they know when they're done? How do they know when they've successfully completed it? Sometimes that's a really easy question. When the code passes a test, when we have answered the question to the satisfaction of an LLM, et cetera. But we don't really know. And as we get into more complicated tasks, right, that termination behavior leads to these loops. Sometimes it can even be self-congratulatory loops. They're no longer trying to solve the problem. They're just really happy to all be here and very proud of one another. And that's a problem. We need them to exit, right, and come up and move on to the next task. And finally, they're unreliable. And obviously, when you, sorry, I'm getting some echo now from Mr. Jasik. You know, when you are dealing with conglomerations of agents, each one itself, right, non-deterministic in its output, you end up obviously with not entirely reliable behavior. And that's something that is a feature to some degree, multi-agent systems that we take advantage of when we use multiple chains of thought. But in day-to-day behavior can be very problematic, right? Something we do need to address, often by constraining the problem space that the agent team is working within to a space that they either have pre-training data on, or we've provided them context within their prompts and their RAG, et cetera, depending on the model we're using to appropriately address problems within that space. So there are mitigations for these, but I'm going to talk about some of the advanced patterns we use to address this within Autogen specifically. So the first pattern are nested chats, and this is kind of just the most basic. This is self-reflection. So these trigger when an agent sends a message. So in this little code block below, and I'll be showing you a full demonstration of each of these 4 patterns I'll be showing you today. When the agent sends a message, the reflection automatically triggers, and a message is sent to another agent to review. So in this case, I have to peek around the camera here. Yeah, I'm actually initiating two chats, one with the senior agent and one with the QA agent. So let's take a look at what that practically looks like in Visual Studio Code. Now I'm going to make this a little bit larger so you guys can see. Try to make it a little larger. Control Shift. No, come on. Well, maybe I won't make it any larger. So this is the code I was just showing you the snippet of. Okay. We register our nested chats. We register two of them with the same trigger. Okay. And our question is, what is the capital of France? Okay. So let's go ahead and run that code and watch what happens. Okay. And here we are using OpenAI's GPT-4o. Okay, so what happened was very interesting. What is the capital of France? Junior agent suggested the capital of France is Paris. Well, we'll see about that. Self-reflection kicked off. Please verify and improve the following answer from junior agent. Capital of France is Paris. And now senior agent, to show off their skills and why they're senior, provided this rather verbose response. And now is proposing we terminate. So now I'm going to hit enter, right? QA agent is now going to chime in here, reviewing the answer. Looks great, terminate. All right, and there we go. There's our full response. We see that this is again, a simple nested chat. You know, what do we got? Less than 80 lines of code. And a very useful pattern for introducing a level of reflection, right? There's a lot that this doesn't do, and that's where we're going to get into these next patterns. One thing I do want to point out, right, is this is termination message, right? This is very common. This is to help determine whether or not the string ended with terminate, and therefore that we need to terminate. The other thing is that you will see I have to do this last message equals junior agent, blah, 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 to find what that query was. Obviously, this could be hard-coded. That's the kind of thing that's just annoying to have to code and gets really complicated in larger interactions. So let's take a look at another pattern. Initiate chat. So I think initiate chats is a little bit more elegant. You're able to, it does run sequentially, but it can be single agents or chats, right? Multiple agents, which in Autogen we would just call, a chat object. It's started by agents.initiate chats. And we're going to do the exact same kind of workflow here using initiate chats. So let's go ahead and take a look at that in VS Code. So here's nested chats. You can see, right, we minus the longer print block here, right? The code is about the same size. We have two group chats, right? So now we have a different interaction pattern where it's a little bit more complicated. All three are there, but we have a different agent kicking it off each time, okay? And let's go ahead and see what this produces. One thing I do want to draw your eye to, right, is that last interaction cost about half a penny. Okay, there we go. We're all done. You can see that was a more complex interaction. We had a lot more transitions that occurred, and we'll talk about what that means, right? But first, we started a new chat. What is the capital of France? Same thing. Junior agent said the capital of France is Paris. Senior agent verified the response, right? Senior agent terminated the chat. That's what we want to see. Then we initiated a second chat sequentially, right? What is the capital of France? capital of France is Paris, right? We brought in context on what the question was. The answer provided previously is correct. The capital, Paris, is not only the political and cultural heart of France, but also a leading center for art, fashion, gastronomy, and culture globally. So senior agent, again, kind of augmenting there. And then we see the final interactions here. Capital of France is Paris. Answer provided previously is correct. So exactly that interaction we expected, but a little bit more, I think, elegant, allows for a lot more complexity in the way these interact. If there was disagreement, we could gain insight from that, and I'll show you what that pattern looks like in a little bit. But this is meant to address some of the complexity, et cetera, that we see, but it's still taking a long time. Still has those kind of issues. So let's move on to yet another pattern. So asynchronous nested chats. This is where things, I think, start getting really interesting. This is where we run multiple chats concurrently, right? So we've got these chats both occurring. And remember, these can include skills. That each of these chats have everything you can do with Autogen. So you can have skills, you can have different transitions, etc. So all of that is embedded in here. And that's important to remember as we go through all these patterns, is that you can combine them in different ways to build more complex applications. Triggers when conditions are met. So you see these prerequisites down here, 0 and 1. So we'll see what that looks like. Again, can be single agents or chats containing multiple agents. And started with agent.a initiate chat. So we always start with an agent because we need someone to send the initial message. So this is who sends the initial message to initiate the chats. So let's take a look at what this pattern looks like in Visual Studio. Okay, so asynchronous code. So obviously, right, we're adding a little bit of complexity. We have to import async IO, for instance, here. And then we also have to have our managers for our group or 2 group chats, okay? And then I've added here a summarizer agent, okay? Who, I'm basically implementing a multiple chain of thought approach. So it's taking the outputs from these 2 first chats, okay? Taking those conclusions and comparing them and letting me know if there's any difference or any insight to gain from the 2 different responses. So also, of course, my definitions, et cetera, here are all a little bit different, but I think the code is really quite beautiful here. So let's watch what happens. Let me expand this because this is going to go pretty quick. Okay, so these 2 chats, as we can see, started simultaneously, right? User sent messages to Group Chat Manager 1 and Group Chat Manager 2. What is the capital of France? Both junior agent and senior agent responded to the capital of France as Paris. QA agent and senior agent validated the responses. The senior agent terminated both chats. Provided the context, summarizer, the capital of France is Paris, the capital of France is Paris, conclusion, both conclusions are identical, right? But you can see how this would implement a multiple chain of thought type approach. And then we print out the full kind of chat that occurred here. So this allows for fan out, right? So here I could have any number of prerequisites, right? And I could have any number of chats and different queues even. So this same kind of pattern could be implemented using something like an AWS SQS or similar, or any queuing service. There's lots of different approaches, but this is a Autogen native approach that I find very simple, elegant, easy to understand, easy to use. So final pattern I want to talk about here is the finite state machine approach. And I see a lot of people confused and thinking you can't do FSM in Autogen, you need lane graph, etc. And that's just not true. That and FSM is not the end all be all by any means. You have to, I feel, right, it's best combined with other models. The easiest way to do FSM in Autogen for me is these transition tables, right? So these are the allowed transitions. And then for any of the chats, okay, you can state, right, speaker transition type allowed, which means it's going to check for this allowed or disallowed speaker transitions. That's the FSM transitions. So let's take a look at what that looks like in code.
Sorry, may I ask what is FSM?
A finite state machine.
Thank you.
Yep. It's an old concept in computer science, and one thing that we're seeing occur is that we're basically like speed running a lot of computer science history, but with LLMs, right? Because there's different approaches that are best applied to LLMs. So we're just learning that steadily, and this is part of the process, right? So let's jump to here. Come on, can I move this out of the way? There we go. I can. Yay. There we go. Go down there. All right, FSM. So this is going to be, a lot of this is going to be very similar, right? But here's our FSM transitions. Okay. Here's that part of the group chat definition that does what we need. Okay. And then we can see very clearly here, right, that the task, right, is the same. Initiate chat, very simple call. Let's go ahead and take a look at what that looks like. And that is it. That is the entire interaction. So obviously the cleanest, simplest, and least costly, right? We're not burning up a bunch of money. We're really optimizing the tokens, etc. Where things get interesting is that I can use, right, this block in my group chat definition over here, right, where I define my group chats. So I could add that block right here. Okay. Boom. Come on. Boom. Did I not copy correctly? I guess I didn't. Well, I'm not going to do it, but you get the idea. Okay. Take this block, which is part of a group chat definition, right? I can apply that to any of my group chats and any of these other points. Okay. So that is it for my major patterns. The next piece I'm going to talk about is the implications of O1 and O1 preview and O1 mini. Okay. The biggest implication appears to be that it is using multiple chain of thought and is performing as a reasonably performant reasoning agent. The reason I say that is because of its performance on planning-based benchmarks, where LLMs have historically, just been completely incapable of handling these challenges. As soon as a little bit of obfuscation was applied, or any kind of extraneous data, etc., LLMs just could not handle. I'm talking about 0.1% success with what's called mystery block roll or blocks roll, versus with O1 preview, 30% plus on that. And that's, again, that's a quantum leap in performance. So that's a huge change. The problem is that per OpenAI's own guidance, we should not be using this as an agent per se, okay? Outside of specific scenarios like O1 Mini as a developer, right? Asking O1 Mini to perform a development task might be an excellent use of O1 today, but using O1 Preview as a planner, for instance, the way it's designed, it's going to attempt to execute that plan. It's not going to, or parts of it, or it's going to structure the plan based on assumptions regarding its own ability to execute. Like, there's a lot to unpack when we're talking about what O1 even is and how it works, because we don't really know. But the net is that how to use it in agentics, we're still figuring it out. Now, the way we start to address some of that is LLM and agent routing. So this is related to task decomposition. But once we decompose a task, and we know from observation that O1 Preview is very good at task decomposition, we then, right, have to decide how to handle each of those tasks. Another thing that O1 Preview seems to be good at is, based on a task, applying an appropriate approach, right? So that I would call more an agent routing type approach, because the approach that the agent will take to solve the problem is usually baked into its prompt to some degree. So which agent should handle which task is very different from which LLM is best for which type of task. And both are important. So this combination, I think, of task decomposition, LLM selection and benchmarking for performance for different types of tasks, especially things like task decomposition. For instance, Claude's supposed to be very good at task decomposition, I've heard, anecdotally, versus agent routing, which is, what is the ideal prompt? What are the ideal skills for an agent to handle this task, or an agent team to handle this task? Finally, all of this brings us to, how is O1 Preview so successful on these benchmarks? Chain of thought, right? Chain of Python, which is using code to work through mathematical problems, or problems that can be best addressed through code, right? And cognitive architectures, I think, are a lot of the areas we need to look into next, coming off the back of the clear success of O1 Preview. So with that premise, O1 Preview is doing very well in these reasoning tasks, far better than LLMs alone, or even basic multi-agent systems, right? How can we build better multi-agent systems that build on the lessons learned from success of
Hello,
O1?
how are you? Hi.
Hi. Sorry, Jose, did you have a question?
I'll mute him. Oh, he's muted.
Okay, all right. Okay, so that's it for the first half here on advanced Autogen patterns. Unless there are any questions or comments, I'm going to jump into the second half on ethics. So any questions or comments on the first half?
Yeah, folks, if you have any questions, please feel free to raise your Zoom hands. And Eric will help answer them.
And it's fine if there are none, yeah.
Right.
I have
Fran,
one
did you have a
actually.
question?
I was actually one of the persons that I thought that in order to effectively do if like how do you say, like FSM, as you said before, you need indeed or either hard code it yourself on Python or using LangGraph. Can we learn a little bit more about the state machines and Autogen in anywhere in the documentation? I have never found.
Yeah, no, absolutely. There's a tutorial page on it. There's a lot of discussion that occurs. One thing that I've seen people get caught up on is that you can do FSM via custom speaker selection. That's viable. It's complicated. I think that the limited speaker transitions provides a good method. But the custom speaker selection approach allows for far more complicated workflows. So, when you're building these up, really think about, do I need dynamic chat speaker selection, or do I need sequential speaker selection, or do I need a strict set of transitions that allows for multiple turns, right? Those are kind of your options. And the nature of the problem, how many skills are involved, and the total context required to solve the problem are all going to influence your choices there.
I see. But from a native way, does Autogen ensure that a call will be responded by an API provider, or do we have to manage that logic ourselves?
Yeah, Autogen will, if a skill call is made to an API, right? So I assume you're talking about like skill calls to APIs, or you're talking about LLM calls to like LLMs?
Both.
Okay. Yeah, either one, there is error handling inside the Autogen platform, but generally, if there's an error, it's going to fail. Okay, so you are responsible for using the error handling, catching those exceptions with try, right? And make sure that you're catching and handling those, right? But generally, if you have your OAI config list properly set up, you know, you're going to, you know, not run into a lot of issues there. And then when it comes to the skill handling, you know, the skills I see are generally very simple. I don't see failures with them very often, practically. Where I see people making mistakes is making overly complicated skills. If you find yourself with a skill that's more than like 10 lines of Python, you probably should be making it more than one skill.
I see.
So I hope
that's a good. I see. And by the way, do you use a lot of Pydantic for your skills, or?
No, I personally don't. I am a mediocre programmer. I see the benefit, but no. I mean, you saw my code. My actual code that I work on is not much more complicated. I'm allergic to complexity. So asynchronous nested chats is like my sweet spot for complexity. I know what's happening. I understand kind of the relationship. And I understand that those async nested chats, those group chat objects, I can apply those limited state transitions. I can add all the skills I want to the agent team. I can modify the agent team. You know, you give me a group chat object, okay, in Autogen, and I can do pretty much anything. And then if you give me task decomp, right, and take that task decomp and load it into an asynchronous initiate chats block, right, you're able to get a lot done very quickly, right, with that concurrent execution. So, you know, that's where I'm allergic to custom transitions. Pydantic, again, I see the value. But I try to stick with the native patterns, not a lot of decorators beyond what is kind of out of the baseline. And that's where I'm moving more toward the patterns you see here. I hope that answers the question.
Yeah, it did.
Any other questions or comments?
I'm not gonna lie, I have so many, but I think that it would be unfair for me to continue. Yeah. So
it's fair. Yeah. We're halfway through. So I think the second half's gonna get real crazy. So
go ahead.
You know, let's dive in. Go ahead.
I think we got one more question. Piyush.
Sure.
Yeah. Hey, Eric. This is again. I'm just trying to think more of a query planner and the task decomposition part of it, right? So, given a user query, right? So, there are two things which are going on, right? So, one, you made a very interesting point, right? So, which is saying, one, every large language model has its own like capabilities within that, and then the task composition also gives you a flexibility to route it to different agents per se and different LLMs, or it could be like but how do you figure out, right? So is there a master LLM? And you said like, so Claude is good at task decomposition part of it.
Right.
So do you recommend, right, the planner piece takes care of the decomposition and with one LLM, and then you have subsequent multi-agent scenario with multiple large language models behind them based on the task. The question primarily is, right, so because of huge latencies, because to answer a simple query, right, so in a multi-agent scenario, there are many calls to large language model which you are making, and token generation takes most of the time, and hence, right, so you end up having huge latencies. So the architecture which you sort of alluded to was, right, so use like both, and you didn't talk about, right, so having large action models or lambs, etc. So I'm just curious to understand like your take with respect to like investing on one versus like truly breaking it down to many microservices or many multi-agents.
Yeah, no, I think that one, it's best not to think of microservices in LLM contexts, right? It brings a lot of baggage with it as a pattern, right? That I don't think it is appropriate in the LLM space. Two, right? Again, I'm allergic to complexity. So I'm going to say have one decomp agent with one LLM behind it, Claude, 4o, whatever, that is dedicated to that task, and you're constantly working on improving that prompt for it, right? Because the every token counts. Every token influences the output. So optimizing prompts for things like your task decomposition agent is absolutely extremely valuable. Two, right? You really have to, consider what your realm of problems are, your problem domain. You can't solve everything. And that influences how you do your task decomp and how many different models you're routing amongst, for what purposes, how many different agent teams you have, how many agents, how many skills, right? You kind of want to optimize the chat to address one problem domain very, very well. That's the ideal in my mind, right? I want an agent team who is extremely good at routing traffic in, traffic lights, right? Handling that scenario. I want an agent team who's very, very good at air traffic control. And that's all it does. Any problem outside of air traffic control, it goes, oh, whoa, no, that's not me. That ain't me. Talk to someone else, right? You're in the wrong spot. I think that has to extend down to our expert systems we're building with these agent teams, right? Because a specialized agent team ultimately is an expert system. And we know what expert systems are from the history of AI, and we know how to use them, right? So building up the right agent teams, building up expert decomposition agents, advancing both sides at the same time, along with continuous evolution of the underlying models. All of that brings us to why the second half of this presentation is so important, which is emergent sentience and ethics. Does that answer your question?
Yeah. No, I understand. Like, so what you are alluding to, which is, right, so make it simple. Just do one thing with one agent, kind of a thing. But yeah, what I wanted to understand is, right, so which you explained briefly, the planner part of it, which you still recommend, right? So, but you are also
we
not
could do an
recommending
hour on task decomp. So what I would
Yeah.
suggest is
but you are not suggesting any large action models kind of thing, right? So which triggers rather than agents, right?
No.
Okay.
Yeah, no. Large action
Understood.
models are an entirely separate kind of field, right? That I think are influenced by agentics, highly relevant. Agentics might eventually adopt LAMs, right? I think there's also a lot of confusion around the terminology because I've seen LAMs being a dedicated technology, and I've also seen LAMs where it looked a lot like just skill calls off of a standard chatbot. So it's another place where I think there's some exciting things happening, but I'm not up to date enough on it. Also, I'm seeing so many different things like DSPy, for instance, DSPY. I look under the covers. It looks a lot like LLM re-ranking, just applied to a wider range of tasks and prompts, kind of like an M-code approach, right? I see a lot of the time, right? I'll look into a brand new approach. Google came out with a RAG approach recently that looked a lot like RAG Fusion from 10 months ago. But that was done by just some guy, not Google. So we'll probably go with the Google version of that terminology. So I guess the point is that we're in such an open flux of technologies and terminologies, et cetera. I'm sticking to my lane, which is Autogen and multi-agent systems, because that's what I know very well. I've spent the last year working with it, working with the community, working at work with it, et cetera. And what I see out of other emergent spaces largely are things that we can emulate in multi-agent chats, which I find really useful to take these new concepts and try my best to emulate them inside of Autogen so that I can compare them apples to apples against another pattern I already have, right? I find that really useful. I find it very difficult when I'm jumping around to these different platforms where a lot of it is hidden from me, the complexity. So for instance, the new Swarms platform, right? I hesitate to say Swarms is new because it's not. But if you dig into
just hierarchical. Yeah.
They hide a lot of the complexity and make it very difficult to do the things I'm doing here in terms of building these larger custom interactions.
Understood. Yeah. Thanks for explaining. Yeah. Thank you.
Yeah. Okay. And one final thought here, everything I've shown, I consider intermediate Autogen, not advanced. But then I realized, what I consider advanced Autogen is really is really applications built on Autogen, right? So these patterns we saw today are about as far as I would recommend going in terms of base Autogen patterns. Higher level stuff should be built with these tools on top of these patterns rather than completely throwing them out the window and doing custom stuff, right? And modifying the underlying library. I've not seen a lot of challenges you can't address with the patterns we reviewed today. Okay. All right.